This is our agenda. First of all, we will see the fundamentals that are required to learn string instruction, and we'll see what are the string instructions that are available. Finally, we'll execute one program, and then at the end, I'll give some assignment to you. Now we'll see the basics that are related to learn this concept. You know very well what is a string. String is a sequence of bytes. The instruction that operates on sequence of bytes. Throughout this topic, I'll be talking about the data transfer, comparing, searching huge data. Whenever you wanted to transfer some huge data means how much, whether it is in megabytes or gigabytes, I'll tell you how much maximum data that you can transfer at one particular operation, that I'll tell you later on. When you compare the string instructions with normal instructions like move, if I say move AL, 5, how much data you are transferring here? Just one byte of data you can transfer. At most, using move, you can transfer not more than 16-bit data. Okay, not more than 16-bit data, but using string instructions, surprisingly, you can transfer so much data. You should understand the most important point, that string instructions are used for effective transfer, compare, search of huge data. So for this purpose, string instructions uses two different types of segments. A data segment, I'll be using data segment, and extra segment. You might be knowing there are 16 segments in 8086, out of which there are 4 active segments: code segment, data segment, extra segment, and stack segment. In our program, we are very first time we are using that extra segment. As of now, we have already used data segment. Very first time we are going to use extra segment now. For string instructions, 2 segments are used: data segment and extra segment. What is the offset of data segment? Highlighting here, look at here, SI. SI is the means source index, is the offset of data segment. What is the offset of extra segment? Destination index. These points already demonstrated as part of segmentation. I'm just clarifying you that I'm going to use these 2 types of segments in as part of string instruction. Right. Look at here, we use 2 locations in 2 different segments to learn string instructions. Source string is stored in data segment, and the destination string comes in extra segment. Basically, you will have an input string in one segment. That segment is data segment. After transferring or after doing some manipulation, that outcome will come in extra segment. We use the offset SI in DS and DI in ES. So this is what the 2 points that tells us. The source string is at a location provided by offset SI in data segment. The destination string is at a location pointed by offset DI in extra segment. The whole point I wanted to convey is that we are going to use data segment. Input string or the source string is available in data segment, and the output string comes to the extra segment. What kind of operation when we perform, how the output comes to extra segment, that we are going to see in short. Here comes a small question to you. Whenever you are transferring some amount of data from one segment to other segment, that amount, the count for string instructions has to be told in only one register. That register is CX. CX is a 16-bit register, you know that. So CL is 8-bit register, CX is 16-bit register. Where we provide the count for 8086 string instructions, come on, answer. CX, 16-bit register, CX. Good. Now let's have this question. You have to answer this question. Everybody who are listening to this video, in case if you have understood this 2 or 3 minutes demonstration, whatever I have done, you should be probably answer this question. Look at the question. In one cycle, if you transfer 1 byte, then how many bytes you could maximum transfer using a string instruction? The amount is told in register CX. You already know CX is a 16-bit register. Now try to answer. If you have any, it's a simple analysis, no doubts about it. In one cycle, that means in one single operation, if you transfer 1 byte, okay, it means that at one iteration, you have transferred 1 byte, such that maximum how much data you can transfer based on the maximum value that you can assign on CX. The answer depends upon the value of CX. If value of CX is 5, then you can transfer 5 bytes. If value of CX is 8, you can transfer 8 bytes. So what is the maximum value that we can keep in CX? The maximum value that we can keep in CX is 2 power 16. If I divide this 2 power 16, 2 power 6 into 2 power 10. 2 power 10 is kilobyte. 2 power 6, the value is 64. So 64 KB. 64 KB is the answer. This question is once given in one of the competitive exams. Now look at our basics continues here. Right. So we are going to ultimately transfer or do some operation of string that is available in data segment, and the outcome or output goes to other segment called as extra segment. Right. This point is already known. Right. So whenever some block or string is given to you, we can traverse either in forward direction or in reverse direction. I repeat, you can travel a string in a reverse direction or in forward direction. For an example, ABC is forward direction, CBA is reverse direction. So how to fix this direction? Okay, the fixing direction takes place in flag register using a bit called as direction flag, DF. Okay, you might be knowing flag register 16 bit, out of which one bit is direction flag, which tells in which particular direction the traversing should take place in the memory, in the segment. Okay, if DF is 0, of course the default value of DF is 0, and in case if you wanted to make it as an auto increment, then you don't have to make direction flag to 0 because the default value is always 0. And in case if you're not pretty sure that DF value is not 0, and if you wanted to make it as 0, then use the command. Okay, CLD, it's an implied command. What do you mean by CLD? Clear direction flag. And in case if you want to make a reverse direction, as long as DF equals to 0, you are moving forward. That means if it is string ABC, then you will be reading it as ABC. As long as DF equals to 0, no problem at all, no problem. In case if you want to make in reverse direction, like if you want to read it like CBA, then you have to ultimately make DF equals to 1. Then you can automatically your offset will be decremented, and of course you will be going towards reverse direction. That means we will start reading the string as CBA. The point that I wanted to convey is very simple. DF equals to 0 forward direction, DF equals to 1 reverse direction. That's all. Now we are getting slowly into the string instructions. Look at these are the 5 important string instructions. Very, very famous question. Okay, right. How many instructions are there? 5. What are they? Move, load, store, compare, scan. Very simple. You have to remember these 5 instructions. Okay, so at any point of time throughout your final year campus placements also, these are most widely used questions. Okay, move, load, store, STORE, the spelling is wrong, don't mind, compare, scan. Okay, right. So for move we have 2 versions. We actually call it as moves. 2 versions. Move SB means move string byte, move SW word, W means word, byte means 8-bit, word means 16-bit. So this is repeated throughout the instructions. You can see B, 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 W, 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 W. B means byte, W means word. I will not be repeating this statement again and again. Remember, B means byte, W means word. Move SB means move string byte. Okay. In the same way, here load. We have 2 versions again: load SB, load SW. Store STOS, compare SMPS, scan SCAS. Right. These are the direct instruction names that are going to be used inside the program to use string instructions. More importantly, we don't use iteration like for loop or jump on conditions or any looping to perform string instructions or to copy some huge data to one location to other location. To repeat the string instruction, which is based on count, that means which is based on CX register value, we use a keyword called as rep, REP. REP stands for repeat. Listen carefully. Whenever you are trying to answer something that is related to string instructions, if your answer do not have this keyword REP, then it is damn waste. So string instruction works only with REP, repeat. It much more just similar to looping. For an example, if I wanted to transfer 8 bytes of data from one segment to another segment, this 8 byte of data continuously based on this 8 value is kept in CX, and this data of some segment, this will be transferred to other segment based on CX value. Now CX value is 8. It means that 8 times we have to iterate. To iterate, you need not to write any looping. REP has to be told. This will automatically check the value of CX based on DF, whether it has to go forward direction or whether it has to, that means whether the value of CX has to be incremented or decremented will be decided. And everything will be taken care by REP. In case if you have learned Python or Java, you might be knowing a bit about automatic iterator. It's a concept of automatic iterator. You don't have to use any additionally some loop. I mean, most of the initialization conditioning is done by automatic iterator. This rep means repeat is very much similar to automatic iterator. Okay, it just looks all the headaches of incrementing, decrementing, looking at the value, conditions, and everything. So, right, how to use this rep? Okay, in case if I want to use this instruction move SB, okay, wherever you are using move SB, then before this instruction you have to use this RE. Right, now we'll see how this is going to work. Right, look at here. The very first instruction, look at here. I'm going to explain now 5 instructions: move, load, store, compare, scan. Examples, please try to understand. Moves, the very first instruction. Look at here, we have 2 segments, okay? One is data segment and other is extra segment, okay? You are going to transfer some data that belongs to data segment to extra segment, okay? Using string instruction. So basically moves does what it transfers, okay? How do you define moves? Moves is a string instruction that transfers some amount of data from data segment to extra segment. In data segment, we use SI, that means source index. In extra segment, we use destination index. The purpose is simple, okay, right? And you can also do the same transfer with move also using an iteration, additional iteration. Using move also you can do. That means move is a normal instruction, but it is not as powerful as moves. String instructions are very powerful when compared to normal instructions, that we have to do these kind of transfers using only string instructions, okay? The idea is very simple. You are going to transfer some amount of data from data segment to extra segment, okay? That is moves, right? This is the general format of moves. In the program, okay, we'll be using only direct statement, move SB, move SW. But so as to make you understand, these 3 instructions I have written additionally, okay? These 3 instructions, okay? What move SB does at one single point of time, you please try to understand, okay? Look at here. Basically, your source string is available in this data segment. You are giving, you are transferring data from data segment to extra segment. In extra segment, we use destination index. Whenever you perform transfer, by the immediately the source index will be incremented by 1 if direction flag equals to 0. It depends upon direction flag. In case if you are going reverse direction of the string, then decrement of source index will be done. Okay, it is either plus or minus. I hope you understand the point. Okay, in forward direction it is plus, in reverse direction it is minus. Okay, because if you are transferring 8 byte of data, after transferring the first byte, you have to come to the second byte. Who has to tell that? The auto increment. Okay, if the source index has to be changed, source index of data segment has to be changed, and the destination index of the destination segment, that is extra segment, has to be changed. For this purpose, increment and decrement has to take place. You got the point? Now, the same. This is very easy to understand. In case if you understand move SB, move SW is 16-bit operation, right? 16-bit. You are not transferring 1 byte at a time. You are transferring 2 byte at a time. I repeat, 2 byte. Okay. The first byte goes to the first byte of data segment goes to the first location of extra segment, and the second byte SI plus 1 goes to the second location of extra segment. Okay, this time, since you are transferring 2 bytes at a time, 16-bit operation, you have to either increment or decrement by 2. Either increment or decrement by 2. You have to, what you have to increment in case if you are going forward direction, source index plus 2. In case of extra segment also you have to do it. Okay, so look at here, very simple. You have transferred the first byte, okay, here to here. Okay, the second byte has to be transferred from here to where? Again, second location only. That's why when you are incrementing SI to one position here, you have to increment DI by one position. In case of 2 byte transfer, you are transferring 2 byte at a time from here to here. Okay, so this goes to this location, this goes to this location. Henceforth, for every iteration, you have to increment SI by 2. By the next iteration, SI should come here, DI should come here. This is what I told you. Very, very simple, very easy to understand. So I repeat one thing. This inside the program, we directly use this instruction. Okay, this instruction directly we use them. Directly we use. We have done with the very first one. Next 2 instructions are based on load and store. I can demonstrate this load and store with using simple diagram here. Look at this diagram. Load and store. The next upcoming two 8086 instructions that I am going to explain now. Very easy to understand. Right. Look at here, data segment and extra segment. Here what we are doing is that we are not directly transferring data from data segment to extra segment. We are loading data to AL or AX register. This is basically accumulator. Okay. Load is used to transfer data from data segment to AL or AX register. Once after transferring data to AL or AX register, then that data to transfer from this accumulator to extra segment, the instruction store is used. Okay. Load is used to transfer data from data segment to accumulator, and store is used to transfer the data from accumulator to extra segment. Okay, good, very nice. And here comes the question. The very first time I'm learning this topic, I got one question. My question is that why load and store? When we have moves, we can transfer directly whatever we want from the data segment directly to the extra segment. We can do that using move SB. Then why load and store? The answer is very easy. It's very easy. So the one point at very initial point we'll get this doubt, and immediately the answer should come to your mind. The answer is that as long as your data, if you don't want to change this data, then directly copy to extra segment. Not a problem, not an issue. Okay. So for an example, I have 8 values here, 8 array values. If I wanted to simply copy from this location to this location, I can use move SB or move SW. But this won't be applicable in case if I want to play with those values. For an example, all these values, if I want to increment by 1 or change according to their nature, then I can't do with move SB or move SW. Initially, I need to load them into the register. I have to do the arithmetic on this particular accumulator, and then I'll store these values to here. Okay. For that reason, load and store are used. I hope you got the point. In your Viva, the question will be like, what is the difference between load, store, and moves? Your answer should be, moves will simply copy the data from data segment to extra segment, whereas load and store are used to manipulate that transfer. That means initially the transfer is taking place in AL or AX. You will be manipulating that particular byte. In case if you are transferring 1 byte, that will be stored in AL. In case if you are transferring 2 byte, if it is word operation, then we use AX. After storing the data, here the manipulation is done. That means if you wanted to increment or decrement, and then store it to extra segment. For an example, how write a program to increment all the values of your array by 1 and store the result in extra segment. You can't do this program using move SB. You have to use load and store. These kind of programs, of course, you have to do. Okay. I hope the point is clear. Now we'll see the nature of load inside the programming. Quite simple. Inside the programming, we'll be using directly load SB. No arguments. Okay. No parameters, nothing. Directly load SB. What load SB does are written in these 2 lines. This is just for understanding, but inside the program we don't write these instructions. Okay. Right now inside the programming, for load 2 byte transfer at a time, that means load word, load string word, we'll be using load SW, and these 3 lines is just for your understanding. Okay. Now let's see what are these 2 lines. Okay. Who is getting value? AL is getting value from where? Data segment to AL. Okay. After getting first value to AL, do you want to increment SI or decrement? Of course, for the repetition of all the bytes, we have to either increment or decrement, and the incrementing and decrementing depends upon a DF. It is user's choice whether you wanted to travel reverse direction or forward direction or reverse direction, depends upon DF value. In the same way, load SW means 16 bit at a time. That means 2 byte. Okay. The first value of data segment goes to AL. Look at here. Now it is 16 bit. Okay. Lower byte goes to AL. Higher byte goes to AH. For an example, if you are going to transfer the value 1, 2, 3, 4. Okay. 3, 4 is the lower byte goes to AL. 1, 2 goes to AH. Okay. So the first value is SI. The second value is, of course, SI plus 1. Since you have transferred 2 bytes of data at a time, you have to either decrement or decrement the SI value by 2. Okay, this is related to lower. Okay, store is pretty easy, very easy. In case you understood the load, then store SD is pretty easy. Look at here, who is getting value? Extra segment. From where? From accumulator. If it is 8-bit transfer, then AL provides the value to DS. Okay, afterward, to ES. And afterwards, since it is extra segment, the offset of extra segment is DA has to be incremented or decremented by 1. First 16-bit operation, first 16-bit operation, yes. Okay, we use STOSW. In this case, lower byte is transferred to ES of DA. The next higher byte is transferred to DI plus 1. That means the first location, in case if your value is 1, 2, 3, 4, 3, 4 is stored in the first location, 1, 2 is stored in the second location of extra segment. Okay, I hope you got the point. Since it is 16-bit operation, your DI has to be incremented or decremented by 2. We are done with 3 string instructions so far. Move, load, store, leftover, compare, and scan. That's all. Okay, right now we'll see how this compare, why this compare is used, and how this has to be used as part of string instructions. We are going to see through a small diagram. Look at here. This is your data segment. This is your extra segment. This is SI. This is DI. Good. Okay. So compare is not used for data transfer. Okay. Basically, you have one string here and you have one string here. Okay. The length of the string is same. The length of the string is same. Okay, string is basically, if it is character, I call it a string. In case this could be an array also, you have some values here, you have some values here. The length of these two are same. Okay, now you need to compare whether the two strings are same or not. Okay, so there are numerous applications of comparison. Where do you think the comparison is used? Wherever you use sorting, comparison has to be done. And comparison is done in most widely is done regular operations in most of the regular operations. Okay, to test whether your two arrays or two strings are equal or not, this comparison has to be done. Okay, in case of two direct values, you could directly do it. With CMP. But this is so many values you have here, and to compare, you need to use a string instruction. Okay, not a normal compare won't help you here. Okay, right. So for an example, if I have ABC here, okay, A will be compared with A, B will be compared with B, C will be compared with C. Every time I'm coming from A to B, SI is incremented. Every time I'm coming A to B here, DI is incremented. I hope you got the point. The comparison can also be done in reverse direction. In that case, SI will be decremented, DI will be decremented. Okay, either ways you can do it. Okay, not a problem. Then after comparison, how will you be knowing whether two strings are equal or not? Very simple. In case of, normally if you are comparing CMP, AL, BL, how will you check the result? You are checking zero flag. Here also you will be checking zero flag only. In case if this comparison is successful, automatically zero flag is affected. Okay, the zero flag, the result becomes 0 and the zero flag is affected. The value of zero flag becomes 1. If zero flag is true, that means your result to the previous instruction's result was 0. It means that the comparison has produced a 0 result. It means that two strings are equal. Okay, very popular question. Write a program in 8086 to compare two strings or two blocks of memory. Okay, how do you write it? You have to write this program. You need to use the string instruction compare. How to use? This way. Okay, look at here. For compare, we use CMP SB, and in case of comparison of one single byte, you can also compare 2 bytes of data at a time using CMP SW string word. Okay, so the rules are same. Here I didn't write the rules because for the 3 previous instructions I have shown you the rules. The same rules are applicable here. Byte transfer, word transfer. Okay, directly we'll be using CMP SB, CMP SW. The last instruction, scan, very important instruction, the most widely used instruction, scan. Right, in scan we'll be using extra segment, no data segment. The value is the value, or basically key value, is provided in AL or AX. If it is 2 byte value, then it has to be kept in AX. If it is 1 byte, then AL. So what is scan? Scan is used to compare this value with all the values that are placed in extra segment. Okay, in extra segment, if you have A, B, C, okay, if basically if A, you wanted to check whether A is present in A, B, C or not, okay, then we have to use the instruction called as scan. So the purpose of scan is for searching a key, So basically in 8086, searching a value in array of elements or in a string, searching a character in a string is done using which string operation? Scan. Okay, so searching is done using scan. Basically, you wanted to check whether the presence of this particular input value inside this set of values or not. This could be done using scan. Okay, so I mean, in one single operation we can do it. You can also do it using normally by comparing this using compare CMP, by writing a manual loop using jump conditions. Also, you can do it, but that is not effective. Scan is very effective. It is string instruction, okay, because it is a string. Good. Now, how to use this scan? Using this scan, SCA. These words you need to remember. Okay, as part of academics, you have to remember scan. Okay, there is no N here. Okay. SCA, SW, and SB. If you are comparing 1 byte, then it is here also. It is much more like comparing. You are comparing only one single value here. Okay, in previous case of compare, you are comparing all the values with all the values of extra segment, and the condition is that the length of this one and then the length of this one should be same. Okay, that comparison will not work here. Here you have only one value here, one value, or you have to compare with all these values. Okay, all these values. Okay, the moment you are comparing, each time the comparison is successful, your DI is incremented by 1. Okay, to travel from forward direction. Okay, in forward direction, your DI is incremented by 1. So we'll be using this. We'll be using this scan SB and scan SW directly. The same rules are applicable. The rules here I'm not writing, but in case of exam, you have to write the rules. The rules I have demonstrated for the first 3 instructions. The same rules are applicable here. Okay. Right. Lastly, we have seen the string instructions, 5 string instructions. Before I teach this topic, I told you one point. If you discuss this topic without rep, then it is waste. Okay, because move SB does only one single transfer. Okay, to repeat for all CX, whatever the CX value it had, for all times, for all the bytes, if you wanted to transfer, then we need to use a keyword called as rep. Okay, repeat prefix in string instructions. This is the topic. There are 2 types of repetitions. Repetition under unconditional repetition, that means without any condition we can repeat, and using conditions also we can repeat. Okay, 2 types. Most widely used is rep. So for an example, rep move SB. Okay, it checks the CX value. If it is 8 times the repetition is done, that means the string the byte transfer is done exactly 8 times based on CX value. 8 times CX value is either incremented or decremented. This headache will be taken care by rep. It's an automatically, it takes the whole work. It does the fantastic job. Basically, I mean, it is much more similar to looping. Okay, rep, repeat. Okay, this is unconditional. What about the conditional repeats? You can repeat by telling some condition here. Look at here, REPE. That means repeat when equal. Repeat when equal. Or this can also be told like this: repeat on 0 flag. Repeat on 0 flag. When do you think 0 flag is set? When the previous instruction value is 0. It means that the previous instruction has produced an equal. If the comparison of previous instruction are same, then the 0 flag is affected. Then you can either use REPZ or REPE. I recommend REPE. I have shown you one example. REPE SCA can be. Okay, I have written it as N here, no N here. SCA SB here. It is SCA SB. Okay, it means that I'll just go to the previous slide. Here, if you wanted to compare, okay, this value with this value. Okay, I'm comparing here. Let us take the input as B, and let us take the values here as ABC. Okay, now if I wanted to B will be compared with the first value A. Do you want to repeat your such? Yes. So if previous instructions is not produced zero flag, zero value, then you have to go from A to B. Okay, as long as zero flag is affected, you have to travel. Am I right? Okay, you have to travel. As long as you find that particular B in this particular values A, B, C. B is tested with A, no match. You have to travel. You should come to B. B will be matched with B. Now zero flag is affected. You have to come out of this search operation because you have successfully found the string, the keyword in your string. To tell, how do you do that? Using this conditional repeats. Okay, repeat on scan or repeat whenever the operation has produced the zero flag, when the operation has not produced the zero flag. Okay, that means the previous operation has, if it is repeat on equal, repeat on not equal. Okay, repeat on not zero, repeat on zero. In either ways you can use it. Okay, I hope you got the point. Unconditional repeats are very usual, very commonly they are used in MOVSB operation, but conditional repeats are used for scan and comparisons. Okay, scan and comparisons we use conditional repeats. Unconditional repeats are used for MOVSB or MOVSW. Okay, right. That's all. This is what I wanted to discuss. In case if you are available in front of my eyes, this topic would have been much more effective, but I hope I made a slight effect to make you understand this concept. Now what I'm going to do is that let's execute one simple program using MOVSB, and more importantly, okay, if you understand, I hope you understand this concept, and remaining all the programs apart from this MOVSB, remaining all other string instructions, you should complete it. Okay, it's your responsibility that you need to complete, right? Now we'll see the execution of. So here is the program that is readily available. I'll explain you this program. Use emulator. Okay, look at here. I've used two segments, data segment and extra segment, right? So in the code segment, I'm initializing the data segment and I'm initializing the extra segment. Okay, and I'm assigning the value of, that means A belongs to data segment, B belongs to extra segment. That means the offset of A I have to place in SI, source index, and the offset of B I need to place in destination index, and I've taken the count 8. Why 8 in CX? Because the input string welcome has 8 strings. I mean, including the last character $, it has 8 values. That 8 values have to transfer. This 8 values have to transfer from A to B. Okay, because I wanted to transfer this welcome from the location A to location B. That means location A belongs to data segment, location B belongs to the extra segment. Okay, so now you see how this MOVSB is going to work. Two simple instructions, REP MOVSB. In one single line also you can write REP space MOVSB like this. It actually one single line only. REP MOVSB. Afterwards, I wanted to show you the result. To show you the result, I have placed 9 value in AH and placing the offset in DX. I called an interrupt, I mean into 21H, which will fire the console output screen showing the welcome as output. So this is the program, and let's see the execution now. I don't do line by line execution. I'll just run this program. At the end, the string welcome is copied in B. Right, we got the output welcome here. Look at here. So this welcome, we got it from extra segment. The offset B here is placed in extra segment.